Hi everyone, my name is Mark Petrikowski, and today I will be talking to you about vitamin D and vitamin E. So I wanted to go over a quick overview of what both of these vitamins are before we get started on each individual ones and kind of their little categories on each of them, and at the end we'll do a research article that I found about one of the vitamins. So, quick overview about both vitamin D and vitamin E is that they're fat soluble. What this means is that they need some fat to be transported in the blood. When in the blood, they travel as cyclomicrons. And then another point about these vitamins is that their excess can be stored. They can be stored in the liver or the fatty tissue. Those are the two main sources where they are stored. And the absorption rate for these vitamins is about 40 to 90%. Another overview, kind of general point about both of them is that diseases can impair their absorption. Different types of health illnesses, diseases, depending kind of where you live and stuff like that, may also affect the absorption of stuff like this, which we'll talk about later on in the presentation. A couple points that aren't up there as well too is that since these are fat-soluble vitamins, they have a higher potential for toxicity. And something that's also up there that you guys may not know is that mineral oils, they also absorb some of the absorption of the vitamins. So they kind of decrease the rate of what is absorbed and what's not absorbed as well too. So let's get started here. The first vitamin I'm talking to you about is vitamin D. Vitamin D is known as the sunshine vitamin, which I'll explain in the next slide. Just kind of general overview. What it meant by the sunshine vitamin is that the UV light can help convert certain forms of cholesterol stuff into a non-active form of the vitamin, but then the body will activate and stuff like that. Vitamin D is also known for controlling blood and calcium levels. This is kind of a big one, which leads to the next point of bone growth, and then kind of helps out with what is absorbed, what's not absorbed, how much is absorbed. It kind of keeps your balance in your body of your bone density and your bone structure. So here's the next slide that I was telling you I was going to explain about the UV light. So kind of just a diagram here on the right side that Dr. Zuniga gave us in the presentation, and it was a great diagram, so I thought we'll use it here. I'll kind of go through and explain. So on the left side of the diagram we have the sun. It gives us ultraviolet light. From this it gives us the provitamin D3, and basically what that does is that the ultraviolet light converts a form of cholesterol into an inactive form of vitamin D or vitamin D3. From there, that goes down to the liver, where the liver converts that vitamin D or vitamin D3 into calcidol. So it takes that vitamin D3 converts it to calcidol, and then that goes down to the kidneys. So then what the kidney will do, if the kidney is stimulated by parathyroid hormone, the kidneys will take that calcidol and convert it to calcitriol. And what that is, that's like the primary active form of vitamin D that the body will use for three kind of main large categories. So then from the kidneys will go down to the three main large categories, the intestine, the bone, and the other tissues. So the intestine, what they'll use, they'll take that calcitriol, and then it will help enhance absorption of calcium and phosphorus, and that's all absorbed in the small intestine. From there, that goes to the whole body. Other form that it can also, or other place that calcitriol can also go to is the bones. This can also help out with different osteoclasts and osteoblasts, breaking down bone, or making new bones, like that. Helps also release the calcium into the bloodstream, and also helps control the rate of bone calcification, so making bone and destroying bone. The other area that calcitrol can also go into is the other tissues, and what that is meant for, that can be used for different kind of cell differentiation activities, stuff like that. So it just helps out with the cell overall. Also to note that vitamin D does not just come from the sun. It can also come from food sources, which we're going to explain here in a little bit. But if you look at the diagram on the far right side, you can see that you can get from food sources. That can be converted to D2 or D3. The small intestine will absorb that with fat, remember, because it's a fat-soluble vitamin. And then they'll be converted to those cyclomicrons, and that goes to the liver, and where the liver again goes to calcitrol, to the kidneys, and then to those three areas there. Some of the recommended allowances for the vitamin D is between the ages of 90 to 50 years old, 5 micrograms is recommended. 51 to 70 years old is 10 micrograms, and 70 plus is 15 micrograms. And as you can tell, as it's a positive correlation between the number of years as you grow older, the more intake you need to make. There's been multiple studies done that show that, especially for women, when they start their menstrual cycle like that, their calcium levels are pretty low like that. So and also eats away at their bone density like that. So they need to keep up with the calcium intake and all that stuff. These numbers here on the screen are predominantly just for men and women. So I could not find the exact numbers for each category like that. But I do know that women need to have more intake of this to help with the bone density, which is kind of more on the calcium side. Anyway, but as you also grow older, your bones also become more brittle, and we'll see a issue that happens with deficiency of this vitamin. So right here we have some vitamin D deficiencies. The main one is the top there on the top right is called rickets. As you can see on the image in that top right corner, the left side of it, the left legs are the normal type of legs, so those are pretty straight up and down. Bones are nice and strong in that one, nice frame and all of that. On the right side is the version which is called rickets. Rickets is defined as a characterized by imperfected calcification, softening, or distortion of bones. They usually result in the bowing of the legs. The reason why is because we carry so much weight from our waist upwards that the legs just can't take that much stress, and then they just soften up a little bit and they bow outwards to compensate for how much weight we have there. Also, what you can see on the bottom left is what we call osteoporosis. This is basically a framework of your bones and showing how thick your bone and how dense your bone is. Basically, think of how strong your bones are as well too. So on the left side, you have your normal bone matrix. It has a little bit of honeycomb shape in there like that, but every part of it looks pretty solid, pretty strong. Not much holes and stuff in there. If you look on the right side of that image, everything looks kind of more like a honeycomb shape. From this, you can tell that it's pretty weak. There is not a lot of structure to it. It's pretty brittle as well too. This is generally what you see in people obviously with vitamin D deficiency, but also people that are older as well too. So that is why they said to keep up with the intake of vitamin D a little bit higher as you grow older. Some toxicity that you have with vitamin D is hypercalcemia, which is, it's defined as like calcium levels in your blood that are above normal levels. What this can mean is that if you have too much calcium in your bloodstream, this can weaken your bones. This can also create kidney stones and interfere with the way how your heart and your brain works. So because of that, this also relates to kind of the other toxicity issues that you see with also muscle weakness, heart arrhythmias, kidney stones, and then the upper limit of that is 50 micrograms. Your daily intake value for vitamin D is right around 400. it is recommended that, as we grow older, it's good to have some supplementation of that as well too. The best source for that supplementation is cod liver oils, and that comes in at 1360. Example of it is on your right side, commonly what you can find in stores and stuff like that. Other sources that are pretty close to the cod liver oils but not as high include salmon, sardines, milk. The next vitamin I want to talk to you about is vitamin E. Vitamin E is also known as alpha tocopherol. Vitamin E is also generalized as an antioxidant, and what this means is that it's going to help out with free radicals, which we'll see here in a little bit. So here's the image of, also in the PowerPoint slide that Dr. Zuniga sent us. Explains it really well as well too, what vitamin E does as helping out with the free radicals. So if you look on the left side of the image, you can see a little small triangle that's represented as vitamin E. Basically what it's meaning is that it donates a free electron that it has, or an electron that has on it, to a free radical, and because of that it helps lowering the damage potential that the free radicals would have done without the help of vitamin E to the membrane molecules. So some recommended intakes and allowances for vitamin E is 15 milligrams. That's all ages, all genders as well too. Also, some of the deficiencies for that is they're kind of rare deficiencies to find with vitamin E, but some of that included are muscle weakness, loss of motor coordination, and hemolytic anemia. What hemolytic anemia means is it's a condition in which the red blood cells are destroyed and are removed from the bloodstream before the normal lifespan is over. As we know from the exercise science classes we've been taking, this is extremely important that we keep our red blood cells in our bloodstream, because they are a big contributor to removing some of the CO2 that's in our blood. And that's kind of one of the most important parts that our body does, is remove that toxic gas in our body. Some of the toxicity that is associated with vitamin E is it decreases the blood clotting, so you have a little bit thinner blood that's not going to clot as easily. This means that, those people who a small cut or a small paper cut or something like that may be life hazardous, something you have to always take care of and be very careful of. Also with toxicity, it's easy bruising, so you bruise a lot easier, and then the upper limit is pretty high. The upper limit is 1,000 milligrams of that. Some of the daily intake, they're pretty much, it's commonly found in a lot of stuff. However, the best source is the wheat bran flakes or total cereal, which comes in around 30 to 42. You can see the image there on the right of what a total cereal brand kind of looks like, the box you probably see in the store everywhere. Other sources are sunflower seeds, almonds, nuts, tomato paste. Those are just a few to list as well too. So then I did a research, or I looked at a research article that kind of combined vitamin D3, as that's kind of sparked an interest for me. And they looked at it that helped prevent hip fractures. So this study has been cited a lot of times. It's been pretty well known news like that. In the study, they took 3,270 women, and their standard deviation age were about 84 plus or 6 minus 6 years of age, so 78 to 90 years of age. This is a longer study, so 18-month study, so this can be problematic for the study of what other outside factors also went with it. Some basic information and the results is half of them received the 1.2 grams of calcium and 20 micrograms of vitamin D3. The other half of the elderly women received a placebo. Big things is the results. 43% of the supplemented women did not fracture their hip, so the hip fractures were lower. 32% were lower non-vertebral fractures that were also supplemented. And then finally, the bone density increased 2.7% for the supplemented, and the decrease that didn't have any of it, placebo effect, was 4.6%. So That being said, I hope you learned something and see the importance of vitamin D and E.